Now see next question from exercise 1.1. Question number 3. Differentiate following with respect to x. First sub question. X square plus 4x plus 1 bracket raised to the power 3 plus x cube minus 5x minus 2 raised to the power 4. So first we denote given value as y. So we write in solution y is equals to x square plus 4x plus 1 raised to the power 3 plus x cube minus 5x minus 2 raised to the power 4. So while differentiating the functions, first we have to apply addition or subtraction rule. So we write here differentiate with respect to x, because we have to differentiate with respect to x. So derivative of y, we write dy by dx. Like solving the problems, we use the rule of Bodomas. That means we first solve the bracket. Likewise, we have to differentiating the functions, we have to apply addition or subtraction rule first, then apply the product rule or quotient rule. So here sign is plus between these two functions. So both the functions are power functions. So we write here first derivative of first function plus derivative of second function. So derivative of y, we write dy by dx. Derivative of first function, so we write d by dx of x square plus 4x plus 1 raised to the power 3 plus derivative of second function d by dx of x cube minus 5x minus 2 raised to the power 4. So here we have to use power rule. So derivative of x raised to the power n is n into x raised to the power n minus 1. So we write power in multiplication. So 3 into x square plus 4x plus 1 raised to the power 2. Now this is composite function. Instead of x, here value is in bracket x square plus 4x plus 1. So we have to differentiate the value of bracket also. So we write into d by dx of x square plus 4x plus 1. So for second function, power is 4. So we write power 4 in multiplication. So we write plus 4 into x cube minus 5x minus 2 raised to the power 3. We reduce power by 1 into derivative of bracket, that is derivative of x cube minus 5x minus 2, because this is also composite form. Now we have to write here 3 into x square plus 4x plus 1 raised to the power 2 as it is. Now we have to differentiate this bracket. So we have to write derivative of first plus derivative of second plus derivative of third. Derivative of x square is twice x. So we write twice x. Derivative of, so here 4 is constant, variable is x. So we have to differentiate this x with respect to x. So we get derivative of x is 1. So we write 4 into 1. Derivative of 1, which is single constant. So we write derivative of 1 as 0 plus 4 into x cube minus 5x minus 2 bracket raised to the power 3 into derivative of x cube is 3x square. Then derivative of minus 5x is minus 5, because we differentiate x with respect to x, its derivative we get 1. So 5 into 1 we write 5 minus 2 is single constant, so its derivative is 0. So we write here 3 in bracket x square plus 4x plus 1 its square. So this 2x plus 4 into 1 is 4. So we write here 2x plus 4, or you can take 2 common, plus 4 in bracket x cube minus 5x minus 2 cube in bracket 3x square minus 5. So in this way you differentiate the algebraic functions. Now see second sub question. 1 plus 4x bracket raised to the power 5 into 3 plus x minus x square bracket raised to the power x. Now these two algebraic functions are in product form. So first we represent given as y equals to 1 plus 4x raised to the power 5, 3 plus x minus x square bracket raised to the power 8. Now this is of the form y is equals to u into v. So while differentiating the product function, so if the functions are in product form, we have to use the product rule, that is dy by dx is equals to first function into derivative of second plus second function into derivative of first, or if you represent by uv, you write u into derivative of v plus v into derivative of u, or you can represent this as first function, this as second function. So we use this product rule for differentiating the given function. So we write here differentiate with respect to x. Therefore dy by dx is equals to first function, or you can say u into, that is in place of u we have value 1 plus 4x raised to the power 5 into d by dx of v, or derivative of second function, that is 3 plus x minus x square bracket raised to the power 8, u into dv by dx plus v into, so here in place of v value is 3 plus x minus x square bracket raised to the power 8 into derivative of u. So in place of u we have value 1 plus 4x raised to the power 5. That means while differentiating the functions which are in product form, we have to apply this product rule. So we write in first product rule form. So keep this first function as it is. Therefore dy by dx is equals to 1 plus 4x raised to the power 5 into, now we have to find a derivative of this. Now this is of the power form, so we write power in multiplication. So we write here into 8 into 3 plus x minus x raised to the power 7. We reduce the power by 1. Then we have to find the derivative of this bracket, because this is composite function. So we write here into d by dx of 3 plus x minus x square. Then keep this second function as it is, plus 3 plus x minus x square raised to the power 8 into d by dx. So we have to again apply power rule. So we write power in multiplication. We reduce the power by 1. So we get power 4 into derivative of this bracket, because this is composite function, 1 plus 4x. Now write the derivative 1 plus 4x raised to the power 5 into 8 into 3 plus x minus x square raised to the power 7. Derivative of 3 is 0. So we have to use addition rule as well as subtraction rule, because first two are in addition form, last in subtraction form. So we have to find derivative of first plus derivative of second minus derivative of third. So 3 is single constant, its derivative is 0. Derivative of x with respect to x is 1 minus derivative of x square is twice x. Then keep this function as it is, 3 plus x minus x square bracket raised to the power 8 into 5 into 1 plus 4x raised to the power 4 into, so 1 is single constant, its derivative is 0. 4 with variable x, so derivative of x with respect to x is 1. So we write 4 into 1, which is equals to, now we have to write this 0 plus 1, that is 1 minus 2x. So we write 8 at first position, 8 into this 1 minus 2x, then this 1 plus 4x raised to the power 5 into 3 plus x minus x square bracket raised to the power 7. Here 0 plus 4 into 1 is 4, so 0 plus 4 we get 4, 4 into 5 we get 20. So we write plus 20 in bracket 3 plus x minus x square bracket raised to the power 8. Then we take 5 in product form. So we write this 1 plus 4x raised to the power bracket raised to the power 4. So you can take 1 plus 4x raised to the power 5 common. and again here 3 plus x minus x raised to the power 2 bracket raised to the power 7 common. So you can write up to this step. Now see sub-question third, x upon root 7 minus 3x. Now this is of the quotient form. So we write in solution first, let y equals to x upon root 7 minus 3x. So you have to write here let y equals to in every problem, because this is not in the form of y. So we write this equation as y equals to. So this is quotient form. So we have to use y is equals to u by v. So we know derivative of y with respect to x as dy by dx. Quotient rule is v into du by dx minus u into dv by dx upon v square. So this x means you consider as function u and this root as function v. So we write here differentiate with respect to x. So derivative of y, we write dy by dx is equals to, in place of v we have this root, so we write here root 7 minus 3x into d by dx of x minus x into d by dx of this root 7 minus 3x upon v square. V square means this root square, so we write 7 minus 3x, its bracket square. So first we apply this quotient rule and put the value of u and v. So we differentiate, so you can write here this as dy by dx. Therefore dy by dx is equals to, so root 7 minus 3x as it is, derivative of x with respect to x is 1 minus x into derivative of root is 1 upon 2 root. So we write here 1 upon 2 root 7 minus 3x. Now this is composite function, so we have to find derivative of value inside this root, that is derivative of 7 minus 3x upon, so here square and square root get cancelled, we get 7 minus 3x. Therefore dy by dx is equals to, so we write this 7 minus 3x into 1 as 7 minus 3x minus x upon 2 root 7 minus 3x into derivative of 7 is single constant, so derivative of 7 is 0. 3 with variable x, so we find derivative of x with respect to x as 1. So 3 into 1 we get 3 upon 7 minus 3x. Now we write first root 7 minus 3x minus, so 0 minus 3 we get minus 3. So 3 into x we get 3x, so minus minus plus, so we write in numerator 3x upon 2 root 7 minus 3x upon 7 minus 3x. So in numerator we cross multiply these two terms. So first we cross multiply these numerator. So we write here 2 into root 7 minus 3x into root 7 minus 3x, that is root 7 minus 3x its square, so square and square root get cancelled. So we write 2 into in bracket 7 minus 3x. Then plus here in denominator value is 1, so 1 into 3x, we write plus 3x upon 2 times root 7 minus 3x upon 7 minus 3x. Now you can write 1 in denominator, so we write here rule of a by b upon c by d is equals to a by b into d by c. So we write here, we multiply also, or you can write this as 2 into 7 minus 3x plus 3x upon, so after writing the reciprocal, this 7 minus 3x write in multiplication with 7 minus 3x. So we get here, when we multiply by 2, we get 14 minus 6x plus 3x upon 2 into. So this power is 1 by 2. When we remove this square root, we write power 1 by 2 and its power is 1. So 1 by 2 plus 1, we write 7 minus 3x raised to the power 3 by 2. So we simplify the numerator, 14 minus 6x plus 3x, which we write minus 3x upon 2 into 7 minus 3x raised to the power 3 by 2. So in this way you have to differentiate the given function. Now you can solve question number 4 with the help of question number 3. Now see question number 5th. 1 plus sin square x bracket raised to the power 2, 1 plus cos square x bracket raised to the power 2. Now these two functions are in product form. So we write in solution given value as y equals to 1 plus sin square x its bracket square into 1 plus cos square x its bracket square. So we use here product rule. So we write here differentiate with respect to x. Therefore dy by dx is equals to first function 1 plus sin square x its bracket square into derivative of second function 1 plus cos square x its bracket square. Now here is cube. So we have use here product rule. First function into derivative of second plus second function into 1 plus cos square x bracket cube into derivative of first function, that is 1 plus sin square x its square. So we write this as 1 plus sin square x bracket square as it is. Here we have to apply power rule first. So we write 3 into 1 plus cos square x into derivative of bracket. So we reduce power by 1. So we write here derivative of 1 plus cos square x raised to the power 3 as 3 into 1 plus cos square x bracket raised to the power 2 into d by dx of this bracket, that is 1 plus cos square x. So we write this cos square x as cos x its bracket square, which will be convenient for differentiating. Then plus 1 plus cos square x bracket cube as it is into, here also we have to apply power rule first. So we write 2 into 1 plus sin square x, we reduce its power by 1, so we get power 1 into d by dx of this bracket. So we write derivative of 1 plus, so we write here sin square as 1 plus sin x its bracket square. Now we have to find a derivative of this bracket. So we write here 1 plus sin square x its bracket square into 3 into 1 plus cos square x its bracket square. Derivative of 1 is 0. So we write 0 plus. Here we have to again apply the power rule for this second function. So we write 2 into cos x raised to the power 1. So we write cos x into derivative of cos x is minus sin x. So we write here minus sin x. Or for your convenience, you write power 1 for cos x. Then plus 1 plus cos square x bracket raised to the power 3 into 2 into 1 plus sin square x raised to the power 1. We write 1 plus sin square x. Then derivative of this bracket, 1 is single constant, so its derivative is 0. Derivative of sin x its bracket square. So we write 2 into sin x raised to the power 1 and derivative of sin x is cos x. So in this way we find the derivative of these two brackets. Now if you simplify, so we write these 3 at first position. So 3 into 1 plus sin square x its bracket square, 1 plus cos square x its bracket square. Here in bracket we get 0 plus. So if we take minus sign at first position, so we write minus 2 sin x into cos x here, plus in bracket 1 plus cos square x bracket cube. So we write this 2 at first position, so plus 2 into 1 plus cos square x bracket cube, this 1 plus sin square x as it is. Here also sin x raised to the power 1, we write sin x, so we write here in bracket 2 sin x into cos x. So you can apply here double angle formula. We know that sin 2x equals to 2 sin x into cos x. So we write for this second term, because here is sin plus, here is sin minus. So we write these 2 sin x into cos x as sin 2x. So we write here sin 2x. So we can take sin 2x common for both terms. So first we write the formula. So sin 2x into 2 into 1 plus cos square x bracket cube 1 plus sin square x. Then for this we write minus sin 2x. So plus minus minus, we write minus sin 2x into 3 into 1 plus sin square x its square 1 plus cos square x bracket square. So you can take here sin 2x common. So we get in bracket 2 into 1 plus cos square x bracket cube into 1 plus sin square x. So we take sin 2x common. So we write minus 3 into 1 plus sin square x bracket square 1 plus cos square x bracket square. So in this way we can solve. If you simplify this, then you have to simplify and write the next step.